So welcome to the second video of Step 0. Here I discuss images and how images can be treated as signals. So before we go into details of this matrix, you see here, let's look at something from the last class. So let's say I have a sampled function, okay, that looks like this. Okay, so let's say this is one, this is two, this is the amplitude. Okay, the red digit represents the amplitude. -1, -2, -1. Let's say it reaches 1 second over this point. Then if I write this the whole function like this, 1 2 1 -1 -2 -1. So this matrix is just a representation of this discrete sample function that you see over here. So basically the point of doing this is to make you understand that every matrix is a signal. So all the matrices you see from now on, the row matrices or column matrices, you can always think them as a signal. Now let's proceed to this big matrix you see here over here. So the first, you can see it has n number of rows and n number of columns. So for an image that's n by n resolution. Now the image looks something like this. All images are matrices of intensities. There are different color schemes, but let us consider grayscale for simplicity. So the most common grayscale scheme used is 8-bit grayscale. 8-bit just means 2 to the power 8 intensity levels. So basically the intensity level vary from 0 to 255. So 0 means completely black pixel and 255 means completely white pixels, and the middle ones get an intermediate gray gradient. Okay, so basically all of the blocks present over here, all of the boxes, they contain the intensity values of the gray level. Okay, so if you consider this matrix to function relationship and just set it for this row number 1, you can see row number 1 can be considered a function under this theory that we just showed to you at first, that any matrices can be represented as functions as a signal. Similarly, for this row, you can make it look like as a signal, discrete signal that is, and for all the rows I can display them as signal. This is also true for all the columns, right? Since the columns are also a matrix, the column matrices can also be represented as signal. So what do we get like from all this? What is the conclusion that we can reach? The conclusion we can reach is all images are composed of a lot of signals, and this signal is not 1D signal like the sine waves we discussed earlier. The sine waves just travel in this one direction. Say t, actually let's say it's x, it will be it's easier to understand that way. So it just goes along one axis, but in our image case we have a row signal and a column signal. So image is a composition of a lot of 2D signals. Okay, so yes, that's how we're gonna use Fourier analysis on our images, like considering them as signals, because our Fourier analysis is supposed to be used on signals. So, and now we have established that our image is a kind of signal. Okay, from this lecture I would like you to just play with some images. There is a function imRead in MATLAB that reads images. Okay, so just take an image and use the imRead function to read the image, store the image in a variable, say img variable. In img variable you are storing the image, then look at the matrix, how the matrix looks. It would be very easier for you if it's a grayscale image, so you can just take any image and just pass it through this function. My bad, it should be RGB to gray. Just use this function and it will be transformed to a grayscale image. Any image you take, it will be transformed to a grayscale image. Okay, so just play around with it, see how the matrix differs and the intensity level differs. And if you want to, you can take one column or one row at a time and then plot it on in 1 second time. So you take the whole row and plot it within 1 second of time. Okay, so the signal looks something like this. I'm not being accurate over here, and it's just an approximation, but you get the gist. So it will look something like this. You can use the stem plot, or you can use the direct plot option. Okay, use both of them. Just play around with it and try to visualize all images as signals. That's it for this video. I'll see you on the next video, where we start with our Fourier intuition.